Hi, in this video we're going to do an experiment that's really important to understand what a sampling distribution is. A sampling distribution is a shortcut, it's a shorthand for the distribution of random samples. Now it gets really abstract really fast, and so that's why I want to make this really concrete by doing an experiment. This is a tool that's extremely important for going forward to inferential statistics. You know, our goal is to take one random sample. That's what we do for a political poll, an opinion poll. Pollsters take one random sample, and from that they give a margin of error, like plus or minus 2, plus or minus 1, plus or minus 50. That's too big, but we need to have an accurate idea of what that margin of error is. So before we can do those kind of calculations or really start understanding what this is all about, we need to understand what is the distribution of all the random samples. Okay, so to make this concrete, I have some data here, and what we're doing is we're pretending to know what the population is just so we can see what the distribution of random samples would look like. Okay, once we understand that, then we'll be able to do some more things. But I have some data from a class survey here. This is one class of statistics students, and it's the number of piercings they have. Okay, so we have, I don't have a frequency scale over here, but we have 1, 2, 3, 4, 5, 6, 7, 8, 9 people who had 0 piercings, 1 with 1, 7 with 2, 1 with 3, 1, 2, 3, 4, 5 people with 4 piercings, no one with 5, 2 had 6, 1 had 7, and 1 person had 16 piercings. Now that is awesome, and I've kept this data set because having the 16 in here really makes it interesting. So you don't have this page in your notes, so don't worry about writing this down. I encourage you to watch this experiment and see if you can predict what's going to happen. Okay, so I have my sampling distribution, or my population actually, in this bucket. So on these little pieces of paper I have written, so this is the person, one person that has 3 piercings. This is the one person with 16. So I have a piece of paper for each colored in space on this histogram. Okay, this is our population. And what I'm going to do is take some random samples, and then we're going to take the average. Okay, this is a sampling distribution for a quantitative variable in which we would take the average. That would be our statistic, the average or mean. Okay, so I'm going to mix them up really well, just like you would for a simple random sample, right? And I'm going to draw 2 students. Okay, now I got 2 and 2. So let me write this down. Again, you don't have to write this down. Sample 1 was 2 and 2. So I'm going to take the average. That would be our statistic. Our mean, or x bar, would be 2 plus 2 is 4 divided by 2 is 2. Okay, so I'm going to do this a couple times, and then I'll fast forward so you don't have to watch this whole thing. But I'm starting over, putting it back in. And I've got 2 different ones. Okay, wow, this time I got 1 and 16. So that's going to be, the average of those 2 is going to be 17 divided by 2. What is that? 8.5? Yeah, 8.5. Okay, and then what I'm also going to do as I'm going forward with this is I'm going to graph these new means. So we're graphing the means, or the averages. And this is a sample size of 2. I'm only surveying 2 people at a time, okay, to show you what happens. So our first time we got a result of 2, an average of 2 piercings, and the second time we got 8.5. So what I'm going to do is round, and so this is going to be 9. I don't have decimal capability on this, so I'm going to round that to 9 piercings. Okay, I'm going to do one more and then I'm going to fast forward a little bit. See if you can, see what you think is going to happen to the shape of this new histogram. Whoops, I dropped them. Okay, here's 2 more. Another sample is 4 and 2. So that is going to be 6 divided by 2, which is 3 piercings. So I'm going to color in 3 right there. Now I'm going to pause this and do like 10 or so, and I will be right back. Okay, so I paused it and I went up to a total of 10 random samples, and I graphed each one here. So notice our original population was skewed to the right, very much skewed, right? And so did you expect that our histogram of random samples would also be skewed to the right? It turns out it is, but notice a couple things. It's actually less skewed. It's coming, our range was 0 to 16, and now it's only 1 to 9. So the whole thing, it actually still looks pretty skewed, doesn't it? But the whole thing is coming in with a smaller range or smaller variation. Why is that happening? So whenever we're averaging, for example, when I drew the 16, I would be averaging that with a much smaller number. So that 16 average with anything is going to be much smaller, right? And same with 0, unless I got 2 zeros, which I didn't, but I could have. There's a lot of zeros in there. I got a lot of 0s and 2s, which gave us a lot of 1s. The only way to get a 0 is to draw 2 zeros at the same time. Okay, so while that's not terribly unlikely, it didn't happen in 10 draws. But any 0 with anything else moves in to the right. So we're getting this kind of narrowing of the distribution. Okay, now you might be thinking 2 is not a very big sample size. So I'm glad you're thinking that. So let's try a sample size of 5 this time. Okay, so I'm going to switch over. I'm going to start over with 1 again and move this up. This time I'm going to draw 5. Okay, so just show you how that's going to look, and then I'll pause it again. That's 4, 5. Okay, so I got 4, 0, 2, 0, 1. Okay, so let me write those down and employ my calculator. 4, 2, 1, 0, 0. Okay, so X bar, actually I don't need the calculator for this yet. 4, 5, 6, 7. 7 divided by 5, so now I do need it. 7 divided by 5 is 1.4. And I'm going to round, again, I'm not going to deal with decimals, so we're going to call that 1. Okay, put them all back in and color in a 1 piercing. Okay, so you don't have to watch all this. I'm going to pause it and see if you can guess what's going to happen in this graph, okay? Okay, so I did 10 samples altogether, drawing 5 students at a time. So random samples of 5 this time, or n equals 5. And look what happened to the graph. So you might notice it still seems a little skewed, but maybe a little less so. Maybe it's getting a little more symmetric. You know, now we've kind of got something that looks like this, whereas the purple we had that, and the original was much more skewed kind of like that, right? Okay, so we're getting possibly more symmetric. We'd have to do more samples than 10 to really know, but it looks like possibly more symmetric. And also look how the range has gone down again. So now that we're averaging 5 people, we're getting more towards the middle. So anytime we get a 16, I think I got a 16 2 times. Yeah, right there and right there. It's still one of the bigger ones, 5 and 4, but because we're averaging with 0s and 2s and even a 4, it's coming way down. So it's coming down to 4 or 5 piercings. Okay, so rather than keep doing this all day, because that takes a while, we're going to switch over to technology, and I'm going to show you a simulation. You're going to have the link in D2L or in the description of this video, and so you can try this with me. So I'm going to jump to the next video, and there I'll show you how to do the simulation. Okay, so I'll see you there.